temperature. Okay. So last time, يا شباب, we introduced, يعني we took a quick summary of the some of the introductory basic concepts and definitions. Okay. And we talked about what's equilibrium state in thermodynamics, and we said whenever we say the state of a substance or a system is this, that means all of these are in equilibrium, which is mechanically, thermally, chemically, and phase-wise. Okay. Also, we talked about two different types of properties. We said we have what we call extensive properties, which depends on the mass. So if you divide your system into subparts, so an extensive property can be all these parts. The property of each part can be summed to find the total property. Okay. On the other hand, an intensive property is a property which is independent of the mass, such as density. If you have 1 kilogram of water or 10 kilogram of water, the density is the same if you have the same temperature, and so on. So another example is the pressure, temperature, and we introduce what we call specific volume, which is how much volume of a substance per 1 kilogram of the matter. Okay. Let's see. Do you have any questions, ya shabab, about previous material? Any question, ya shabab? طيب. So today يا شباب تسمعوني صح؟ بس عشان to be sure you are following with me.
Yes, we can hear you.
Yes.
Today يا شباب I want to talk about, يعني try to quickly introduce two different perspectives of thermodynamics. Okay. Let me just. So when you look at thermodynamics, طبعا احنا قلنا we will talk about the units today, but before talking about the units, let me introduce two ways we can look at thermodynamics. Okay. And these different perspectives are important for you, Shabab, to understand. Yani, whenever you hear thermodynamics, right now you know what thermodynamics is about. But how do we analyze problems in thermodynamics? How do we look at systems in thermodynamics? Okay. So the first view of thermodynamics, it's what we call classical thermodynamics. Okay. And the other view is what we call statistical thermodynamics. أنا ليش أبغى يعني explain to you this so that you can be aware of the different views of thermodynamics, and even in the future, inshallah, if you're interested to continue in this field, for example, you can see which view you can be يعني go into details and deeper understanding of the topic. Okay. So what do we mean by classical thermodynamics? Okay. Or another word for it is macroscopic view. So we look at thermodynamics in a macroscopic view, The statistical thermodynamics, we look at it as a microscopic view. What do you think, ya shabab? Can you guess what's this about? Yani, let's look at the macroscopic view or the classical thermodynamics. What do you think it's about? Shabab.
On a much more specific way.
Okay. We talked also about it a little bit when we looked at, if I remember, when we said, did we talk about it or not? Or no? Or maybe not yet. Okay. Let me ask you a question. If you have a bottle and you have water here, and tell you what is the temperature of this water, what do?
Put a thermometer or something.
If you want to measure it, you'll bring a thermometer or some device to measure the temperature.
Yeah.
لما تبي تحطها وين بتحطها؟
Inside the cup.
Inside, صح؟
Yes.
Someone will come and put it here. Someone else will come and put it here. Someone else maybe put it here. هذه
doesn't affect.
لا, but the question is, if you want to get an accurate reading, what do you usually do? Or this temperature here, why did we? Is it representing the whole system or not? That's the question.
Should be, yeah.
Actually, you don't know, right? Like, let's say if you are heating your system, for example, maybe the heat here is higher than the heat here. So maybe if you get temperature here, it might be different from the temperature here, صح?
Yes, kinda.
So what do you think is the best way to do it?
Put in the middle or in the top.
Okay.
Another
idea. We can take multiple readings, صح? So maybe you can take 1 point here, 1 here. Let's say you can take here, here. Multiple readings, and then at the end, what do we do? Maybe we take what? The average. Okay. The classical thermodynamics, ya shabab, look at systems as if they are average properties. So when you talk about the properties of the system, you look at it in terms of what? Overall behavior. Overall behavior of the system. Okay. فلما نتكلم يا شباب مثلا in this course and say I have a piston cylinder arrangement and I have gas inside, for example, the temperature of this gas at state 1 is, let's say, 100 degrees Celsius, for example. What I'm referring to 100 here is an average temperature of the whole system, okay, or overall behavior. However, if you look into each part here, maybe each location, and this location correspond to what, ya shabab? Correspond to microscopic level. If you look at molecules here, molecular structure. If you look at the molecular structure behavior and you try to study the effect of this molecular structure properties on the whole system, this is what we call microscopic view of thermodynamics or statistical thermodynamics. Why do we call it statistical? شان statistics? Statistics is الإحصاء. So usually we look at the molecular structure of these molecules and then we use a statistical means, يعني طرق إحصائية, in order to analyze the system. okay, or to solve or to understand the behavior of the system based on statistical means, based on molecular structure. However, in classical thermodynamics, and specifically in this course, Shabab, this course is focusing on the classical view. We look usually at the overall behavior of the system. So we don't try to go into deep into molecular structure to understand the behavior. Okay? Lakin if you go into the microstructure, you might find these molecules here have different temperature than the other part, then the down, maybe in the middle, etc. Okay? However, we just simplify the problem and find the average properties, or look at the average properties overall. أي سؤال؟ فهمتم الفرق يا شباب؟ Any question? Any question? عشان كذا يا شباب ترى في مواد يعني offered by some universities or some departments, we might have this as well here, that look at statistical thermodynamics. It's different from classical. الشيء المهم الثاني لازم تعرفونه يا شباب انه how did we find this? How did we say that this overall structure is correct? يعني why did we come up with classical thermodynamics? What do you think? And how do we know this is correct and this overall behavior is right?
Because we suppose that the system is in equilibrium, I think.
Okay.
Also by experiments.
قاعد أقول ممتاز يعني we did experiments, but what did we do when we did experiments? We studied the molecular structure thermodynamics, the statistical thermodynamics, and based on it we developed the overall or average or classical thermodynamics. So the other important thing to know is that the classical thermodynamics is actually based on the statistical thermodynamics. لأن في الأخير
دكتور صوتك
يس
صوتك قطع فترة.
رجع شباب.
اي هو رجع لكن ما اتضح الجواب للسؤال كذا بدأت في نص.
I will repeat.
تعيده؟
Yes, I will repeat. الكل برضو سمع الصوت ينقطع ولا عند الرجال بس؟
أتوقع عنده بس.
Okay. طيب check your internet يعني إذا أنه عندك مشكلة. But I will repeat, not a problem. اللي كنت أقوله إنه classical thermodynamics. Okay. So when we look at the overall behavior, how did we prove that this overall behavior is correct? We related it to the statistical or microstructure behavior. معناته classical thermodynamics is actually based on the statistical thermodynamics. يعني جايوا سووا experiment, they looked at the macrostructure and they did statistical means to find average based on what? Based on multiple points, or based on, in this case, based on the molecular structure behavior. Okay? And then based on that, they come up with the overall behavior of the system that they proved it's correct. Then they come up with this view of the macroscopic thermodynamics. Okay? So just this is another important piece of information to know that the classical thermodynamics is based on the statistical thermodynamics. Let's see if they have أي سؤال يا شباب؟ أي سؤال؟
نعم دكتور، أنت في المثال جبت عن الحرارة، قلت إن ناخذ الافرج. طيب لو تكلمنا عن الكتلة أو مثلا أو الوزن راح يكون نفسه صح؟ ما راح يتغير من نقطة لنقطة.
لا نفس الشيء. نفس الشيء. كيف ما راح يتغير؟ لما تاخذ مثلا a number of molecules تاخذ another higher number. انت تتكلم الماس، ممكن الماس is يعني الماس is it's fixed, or you know what the mass is, right? But when we talk about important properties يعني مثلا internal energy, مثلا pressure, temperature, these stuff that we are talking about. Okay? يعني not necessarily only the mass. يعني انتم عارفين مثلا اعطيكم مثال بسيط جدا، مثال بسيط. تعرفون الانترنال انرجي اللي خدتوها في الفيزيكس صح؟ اليو تذكرونها؟
اي نعم.
وش الانترنال انرجي؟ الحين لو عندك اي ماتيريال solid gas liquid it has internal energy some value. اوكي طيب الانترنال انرجي هذه مرتبطه بايش؟ ليش انا عندي شيء اسمه internal energy؟ مرتبطه بالمولكيولز they are rotating they are vibrating they are translating they are in movement. Even the solid they have internal energy but the motion is less. مثلا liquid has higher for example energy maybe the gas is even more. So هذه يا شباب how did they, and then for classical thermodynamics if you will see later we talk about U have a certain value, but actually how did they find this U? They summed all the energies related to rotation, related to vibration, related to translation, and this is statistical thermodynamics. Okay, so they did statistical thermo on these molecules to come up with the average internal energy for this specific matter or substance or system. Is this clear?
Yes.
Okay. Good question. Okay, let's see. Right. Let's move on. Don't want to spend a lot of time here. Okay. So, another thing is that the classical usually is less mathematically complicated than the statistical. Statistical involves more mathematical complexities. Okay. I just want to summarize this again. We said this is molecular structure. Okay. Right. So this is what I wanted to discuss with you today, before we go down to units. Okay. So let's talk about now units. Dimensions and units. تكلمنا عن اليونتس آخر مرة ولا لا؟ لا لسه صح؟
لا لسه.
اوكي.
اعطيتنا فكرة هذه اكثر شيء يغلطون فيها الطلاب يعني.
Yes. So that's why I want a little bit focus on it. So this is very important يا شباب. اغلب الطلاب زي ما قال زميلكم يغلطون في اليونتس، والحين انا اقول لكم الحين تراك تغلط في اليونتس. معليش يعني. طيب ما في واحد يقول لا ما راح اغلط. يعني مرة كذا خلاص صدقتم. هو this is a fact انه most students they make mistake in units. ليش؟ لانه they miss مثلا multiplication, they miss division by some conversion factor, they forget what the conversion factor is مثلا from bar to or from atmosphere to Pascal, stuff like this. Okay, but let's talk about it a little bit, and I will teach you يا شباب a simple way to go about converting units. Okay, and this way if you follow the procedure very well, inshallah you will not make any mistake. Okay, and you need to practice that procedure. But before, let me introduce what we call primary dimensions. Okay, and then what we have, what we call secondary dimension. اوكي. الخط اليوم كويس صح؟
مرة.
جلست اتدرب وكذا. No, just kidding. Okay. لأنه I was missing my writing pad, but now I have it. طيب عندنا يا شباب what are the primary units؟ The primary units يا شباب بكل بساطة اللي هي the most basic unit that exists. يعني أي شيء the smallest units possible. مثل إيش يا شباب؟ مثل خلينا نقول الماس. What is the unit of mass؟
كيلوغرام.
كيلوغرام.
This is what we call SI units. تعرفون ال SI اللي هو International Standard of Units. Okay.
Yes.
International kilogram. وش البريتش system or الانجلش system؟
باوند.
في الماس الباوند. Pound mass. Okay. طيب what is the other basic unit؟ ها what do you think؟
متر.
اللي هو ايش؟ اللي هو length.
لينث.
صح؟ meter in English we call it feet. Okay. What else? What is another basic unit?
Time.
Time. So time is correct. Second. All right. And the last basic unit is related to temperature.
كلفن.
Exactly. Which is the Kelvin scale. All right. In English, we call it degrees Fahrenheit. Okay. So these are the most basic units. Yani this unit is not made up of anything. Yani this is the smallest thing possible. طيب وش secondary unit? Secondary unit يا شباب is whatever you can make of the primary unit. يعني أي شيء أي dimension that is made up of the primary units. مثل إيش؟
M/S.
اللي هو إيش؟
velocity.
Velocity. Exactly. Excellent. So we have meter per second. مثلا. Okay. أو ممكن يكون هنا feet per second. This is I. This is English. Okay. What else? مثلا another example. ممكن volume, right? Volume is made up of the meter, so this is meter cube. This is feet cubed. أي example ثاني يا شباب؟ عندك مثلا
الجول.
الجول الانرجي. Yes. Also you have force maybe. The force is Newton, which is what? Newton اللي هو kilogram meter per second square, or we call it in the English system is bound force. We have what we call bound force. And so on. يعني the examples are many for the secondary dimensions. Okay? So these are the main difference between primary dimensions and secondary dimensions. أي سؤال هنا؟ أي سؤال؟ Okay. I guess this is clear, inshallah. So let's talk about also large versus small numbers, and these are also related to the conversion factor. Okay, large versus small numbers.
Doctor, before you go on, can you tell me what is the SI unit for the pressure?
The pressure, وش pressure? Yes, we can talk about pressure. You took it in the physics, يعني. Remember?
Yes, but there is more than one unit, and I got messed up a little bit.
I will talk about pressure specifically, inshallah. And okay, very good question. I know pressure is very important property in this course. The primary unit for it, or the SI unit, is what we call Pascal. Okay. الباسكال هو ايش؟ عبارة عن نيوتن per meter square. هذا الباسكال. Okay, Newton per meter square. And as I said, Newton is kilogram times meter per second square. Okay. So this is the SI units for the pressure. Then you have other pressure values or sorry units. يعني مثلا عندك bar, عندك atmosphere, عندك maybe millimeter mercury, etc. All of these just different units that you can convert between Pascal and these units. Okay. The other thing, maybe we have megapascal, maybe we have kilopascal. All right. And this is actually what when I talk about regarding large versus small numbers. واضح جاوبتك أنا؟ Did I answer?
نعم.
Okay. Good. الحين يا شباب as I said لو عندنا مثلا قيمة جدا عالية زي ما قلنا قبل شوي مثلا الاتموسفيريك بريشر مثلا أو ولا خلينا نقول pressure inside combustion chamber of an engine يعني محرك السيارة يصير فيه احتراق جوا فالبريشر عالي جدا ف how do we represent this pressure يعني هل معقول إني أكتب مثلا مثلا زي كذا مثلا 10 مليون باسكال مثلا I need some abbreviation that can represent these large numbers. Okay. Any idea, Shabab? Do you have any idea about this?
Using the scientific notation.
Exactly. So we use scientific notations to represent large versus small numbers. For example, we can use 10 to the power 12. This is what we call, Shabab, this is what we call tera. And it has the letter T. فلما يكون عندي مثلا pressure مرة عالي يعني I don't know what is this, but let's say we have tera pascal. It's possible, okay? So tera here represents 10 to the 12. One of the most common ones that you always see يعني in many places is that when you drive your car you have 10 to the power 3 اللي هو ايش؟ kilo. It has a letter K. Okay, so usually when you drive your car, you have the speed as kilometer. وش يعني kilometer? Kilo is 10 to the 3 meter or 1000 meter. Okay, so these are the notations that we use to represent large versus a small number. Some of the others, ya shabab, is 10 to the 9 is what we call. Shabab, 10 to the 9 is we call
Mega. Giga.
Giga, which is G. 10 to the 6.
That's mega.
This is mega. Okay. M. طبعا, if we go to the negative, the power is negative. Let's say 10 to minus 3. This is what we call it.
Milli.
Exactly. So this is milli. It has also letter M. You have 10 to minus 6 is what we call
Micro.
micro.
Which is U.
U. You have 10 to minus 9 is what we call nano.
Nano.
Okay. فلما تسمعون يا شباب والله this is nano technology مثلا. وش قصدهم nano technology? The size, the scale is in the 10 to minus 9 meter. 10 to minus 9 nanometer or nanometer. This is what we mean by nano technology or nanoscale. Okay. And so on يعني. Okay. أي سؤال على هذه يا شباب؟ أي سؤال على هذه؟ So فبالتالي يا شباب لما نتكلم عن اليونت, if we go back now to the unit, when we talk about megapascal, okay, and you are solving your problem, if you are working with SI units, you need to convert everything to SI units. يعني إذا عندك equation مثلا تبغى توجد مجهول مثلا وعندك equation والايكويشنز فيها multiple parameters, maybe pressure, maybe temperature, maybe length. Okay, so if you want to convert, you need usually, if you are working with SI units, to find the correct answer you need to convert everything to SI units. فمثلا عندي mega pascal, so what do? I take the number and multiply it by, let's say 10 to the 6 ويصير pascal. تخيل ان عندي temperature which is in degrees Celsius, let's say 10 degrees Celsius. How do you convert it to Kelvin?
Plus 273.15.
Exactly. So you add the conversion factor. Okay, so the temperature in Kelvin equals temperature in degrees Celsius plus 273.15. Okay, we'll talk about also temperature later. So this is the importance يا شباب of unit conversion. I will give you a question now يا شباب. I will give you 5 minutes to try to solve it. Okay, so this is a practice problem for you so that you can practice unit conversion. Okay, let me give you this question. Please prepare a pen and pencil or pencil and paper. Okay. Okay, the question is, car driving at okay 100 mile per hour for 120 minutes. Okay, find the distance traveled in meters. يلا شباب, please I want you to find the answer for this question. I need you to practice how can you find the answer after doing after applying the distance equation and using unit conversion. And then based on this I will explain يا شباب, I will solve it and explain you the procedure and you can follow with me or right or wrong. يلا يا شباب, الحين 8:37. I will ask you to stop at 8:42. I will ask the right answer after 5 minutes. Go ahead يا شباب.
دكتور احس السؤال ناقص ولا مترز بر ايش تبغى يا دكتور؟
متر. ابغى الديستنس traveled in
distance. معليش حسبت الصراحه معليش.
I need the distance traveled in meters. You have the speed and you have the time and then you find the distance, but I need it in meters. تبغون اليونت conversion factors يا شباب؟ Shall I give you conversion factor?
اللي عنده فورد بيعرف.
عنده؟
اللي عنده فورد بيعرف.
قول لي. طيب let me give you the one maybe not everyone knows, اللي هو 1 mile equals to what? It's around 1.6 kilometers. Okay. شباب, this is a practice for you. يعني it's really beneficial for you if you try it. يعني it will help you a lot. Okay.
أظن طلعت الجواب يا دكتور.
طيب, let's wait couple minutes and then I will ask you about the answer. طيب يا شباب, طيب يلا, what's the answer اللي شوي.
3.2 times 10 to the power 5.
3.2 times 10 to the power
5.
meter.
Yes.
طيب, أي أحد عنده other answer?
If it's 3.2, it's not in meter.
لا, بس هو قال 10 to the power 5.
Oh, yes.
3.2 10 power of 6.
6. أوكي. طيب, أي أحد آخر, أي جواب آخر؟ الحين عندنا جوابين. شباب,
320 kilometers.
320 kilometers. أوكي, يعني in meters كم؟
Same as the other students. 3.2 to the times 10 to the power 5.
Okay. So, okay, that's actually the right answer. But let me say, يعني لو تلاحظون, maybe one of you made some mistake somewhere and he got يعني 10 to the power 6. Okay. طبعا الجواب الصح زي ما قلنا اللي هو 320,000 متر, 320,000. Okay. So how can we find يا شباب the right answer without making any mistake? يعني we make sure that we do not make mistake يعني at all. Okay. So let me tell you how we can do this. This procedure يا شباب is what we call unit cancellation. Unit cancellation. وش الunit cancellation؟ بكل بساطة يا شباب, احنا we try to cancel units that we do not desire. Okay. So first of all, when we read the question, we know that the answer is basically distance equals ايش؟ velocity times the time. صح؟ المسافة تساوي السرعة بالزمن. This is a basic equation. Okay. So we know that the velocity is in terms of what? So the velocity, where's the velocity? I have it here, is 100 miles per hour times the time. The time is, I know I have it in minutes, so it's 120 minutes. Okay? أقدر أضرب هذه في هذه وخلاص؟ ها شباب؟ Is this
No.
correct? We multiply just this mile per hour times minutes. This will give you يعني new unit. يعني it's not the right one. So what do you need? You need to convert this here into what?
Into seconds or
Into-
minutes.
يعني you need to cancel the time anyway, so it's either you keep it in hour or you change it to minutes. يعني it's up to you. So what we can do is let's change it into minutes. So the first step يا شباب, if I need to cancel the hour, أجي هنا وطالع أشوف إن الأور فوق ولا تحت. بالبطن المقام ألاحظ إنه تحت. معناته اللي بكنسل وين وش بسوي؟ وعندي أنا أعرف إنه 1 hour equals what? 60 minutes.
60 minutes.
ممتاز. ال 1 hour equals 60 minutes. والأور اللي أبغى أكنسلها تحت، صح؟ وش أسوي؟ أسوي ضرب، أسوي fraction like this. ما دام الأور تحت اللي بكنسلها، معناته عشان تتكنسل الأور وين لازم تكون الكونفرجن حقها؟ فوق، صح؟ بعدها وش أشوف؟ وش أسوي؟ خلاص حطيت الأور فوق، بعدها أكتب الكونفرجنز اللي موجودة عندي. 1 hour 60 minutes. Okay? In this way now I can cancel the hour line. طيب, the next step, what do I need? الحين خلاص المينتس عندي are unified here and here, so I'm good. This is fine. طيب, the next step I want to cancel ايش؟ المايل and change it into meters. So what I do, another fraction. طيب, المايل فوق ولا تحت؟ فوق، معناته عشان اكنسلها لازم يكون تحت. طيب, الكونفرجن حقه وشو؟ 1 مايل 1.6 كيلومتر. So احط هنا 1 مايل، هنا احط 1.6 kilometer. This is kilometer. I still have to change kilometer into meter. So الكيلومتر فوق ابغى اكنسلها احطه تحت هنا، بعدين اقول انه ال 1 kilometer equals what? 1000 meters. And that's it. شوفون كيف طريقة الكانسليشن. I see is it up or down, then put the conversion on the other side, and then write down the conversion fact. Very simple, very straight way, very clear. يعني you don't make any mistake if you follow this procedure. Now if you do this, the mile will cancel with the mile, the minutes goes with minutes, hour, sorry about that, the hour goes with this hour, and then last thing you have the kilometer goes with the kilometers, then you are left with the meter. So what do you do? 100 ضرب 120 تقسيم 60 ضرب 1.6 ضرب 1000. That's it. يعني you just multiply these numbers and divide by whatever numbers in the down there, and then that's it. You get the final answer. اللي هي زي ما قلنا 320,000 meters. Okay? In other ways, you can say 320 kilometers, or as your friend mentioned, 3.2 times 10 to the 5 meters. خلينا نشيل كيلومتر. اوكي يا شباب؟ That's it. أي سؤال هنا يا شباب على البروسيجر؟ إيش رأيكم في البروسيجر؟ ممكن تعرفونها قبل، لكن if you follow this procedure in a clear way as I explained, you will not have any trouble inshallah in the unit conversion. نفس الفكرة يا شباب، احنا تكلمنا هنا عن متر وكيلومتر ومايل، نفس الفكرة لو تكلمنا عن ايش؟ لو تكلمنا عن pressure. We know that 1 bar equals 10 to the 5 Pascal. Okay? So 1 bar equals 10 to the 5 Pascal. فلو عندك مثلا 3.2 bar and I want to change it to Pascal, what do? I want to cancel the bar, so I put the bar here. So 1 bar is 10 to the 5 Pascal. So bar plus bar, then you multiply this number by this factor, and so on. Okay? So if you follow this procedure, بإذن الله يعني, I assure you that you will not have any problem with unit conversion. Just be clear. وانتبهوا يا شباب من اليونت conversion في العقل، تحطها في عقلك كذا، تحول في عقلك. You convert in your mind. I know some of you can do it, which is fine, but even if you know for sure, I usually write it down. It's better to write it down. لأنه يا شباب I saw this يعني multiple times. People do the conversion in their head and then they write the final answer, which is wrong. Okay? So please put everything down on the paper. It's much better for you. ها شباب سؤال؟ أي سؤال؟
طيب يا دكتور، هل المفروض ان نحفظ كل الكونفرجن فاكتورز مثلا المايل وهذه الاشياء؟
Yes. في الثيرموداينامكس يا شباب ما في شيء اسمه فورمولا شيت، ما في شيء اسمه you will need to remember everything.
Every conversion factor.
حتى
Okay, thank you so much.
أي سؤال ثاني؟ أي سؤال ثاني؟ Okay شباب. All right, so I will inshallah now يعني in today I will try to upload this unit this notes, sorry. I'll upload these notes for you inshallah in the Blackboard. Okay, I was busy this weekend, so I did not do it, but I will upload for you inshallah the notes.
Will you upload the lecture on YouTube, Doctor?
I will upload it also inshallah. Okay. So let me just take attendance. Give me a second. خلاص يا شباب. You can leave.
Thank you, Doctor.
Thank you, Dr.